Hi everyone, welcome back to our channel. Today we are going to understand about what is meant by Tellegens Theorem. Okay. Basically, Tellegens Theorem is a fundamental theorem in electrical circuit analysis. It is applied to any lumped network. Okay, so lumped network means this we call it as a lumped network where the value of resistance is easily defined. Okay, if the value is restricted to an value, then it is called lumped elements. Okay, therefore we can apply this Thevenin's theorem to an electrical network consisting of lumped network means small resistive network of interconnected components. So what is the statement of this Tellegen's theorem is the algebraic sum of powers delivered by a branch of an electrical network is zero. So we can call it as the algebraic sum of voltage in current is called power, that is equal to algebraic sum of voltage and current. So this is the voltage and current by the power delivered by the source. This is the power delivered by the load. Okay, so power delivered by the source is equal to power delivered by the elements is equal. The meaning is that the power delivered by the sources in the network is always equal to the total power absorbed by the elements. This is the total power absorbed. Okay, so we can call it as the total sum of powers delivered by the sources is equal to the sum of powers absorbed or sum of powers absorbed or delivered by the loads. If the powers are same, then we can validate it. Okay. So in order to validate it, I am going to do the problem in lecture 54. You can see here. So this is an verification of Tellegen's theorem. So all the 47 is one resistor, I mean T network, and 2000 ohms, 500 ohms, 47 ohms, 2000 and 500. To this network, what happens is we need to find out the power delivered by this voltage source and what is the total current I1. Okay, so what is the power delivered by this source? So voltage is already known and current we have to find out. So the sum of 30 into I1 plus 30 volts into I2, so this sum should be equal to power consumed by the 47 ohm, power consumed by the 2000 ohm, power consumed by the 547 ohm, power consumed by the 2000 ohm, and power consumed by the 500. So the power generated by the sources is equal to the power consumed by the loads or power consumed by the loads. Okay, so this is called Tellegen's theorem. This validation is called Tellegen's theorem. So what is this mathematically is? So this is the power delivered is the product of voltage and current. Short notation is a product of voltage of the voltage source and current delivered by the source. This theorem is derived from KCL. Why? Because KCL means currents are there. That's why this is derived from the KCL. Since voltages are there, they are derived from the KCL and KVL. So this is a very important point. So Tellegen's theorem is derived from the product of voltage into current. It is derived from Kirchhoff's current law as well as from the Kirchhoff's voltage law. It is applied to an linear, non-linear, passive, and time invariant and time variant. Okay, so linear means so the elements, this theorem we can apply where you have linear elements RLC and non-linear for diode, for transistors and BJTs. Okay, all those elements also you can apply this Tellegen's theorem. And passive. So passive means we generally call it as a energy consuming, which are nothing but resistor, inductor, capacitor. Okay, if a network consisting of resistor, inductor, capacitor, transistors by BJT and all these networks, and for time, if they are varying with respect to time or if they are constant with respect to time. So constant with respect to time is for a DC supply. Constant which are varying with respect to time is nothing but AC supply. Okay. So for all these elements and sources, we can apply Tellegen's theorem, and we can prove that what is the power consumed by the different resistors. Okay. So here the source is delivering, but source is delivering the power, but whether energy is really consumed or not, we can identify with the help of this theorem. Okay. So next one, what is the practical significance of this theorem for the need of study? So this is helpful in energy conservation. If you want to save the energy, so we can understand what is the energy generated by the sources, what is the energy consumed by the different resistance, we can find out. So this is helpful in energy, finding out what is the energy consumption of the network, what is the total power generated is equal to total power consumed. Okay, and this is also useful in error detection. So useful to verify the correction of circuit, network analysis. So somewhere, for example, we applied some sort of 600. For example, if this problem only, if you consider, so totally we are going to generate 826 milliwatts. Either 826 milliwatts is consumed by all these six elements or not, we can verify. It is called error detection. If it is consumed more, where it is consumed more, how the resistance has been changed. So this also useful in error detection. This you can see here. This is a electrical circuit one. This is electrical circuit two. This is electrical circuit three. So group of electrical circuit, we can call this diagram as an electrical network. For all these complex electrical networks, we can apply our Tellegens theorem. So this is applied to any network regardless of its complexity. So generally, if you want to solve this problem, it's very complicated. Why? Because here you are going to have node 1 and here you are going to have node 2. We have to use nodal analysis and we have to find out the currents in each branch and you have to find out all these things. That's why for this complex analysis also we can apply our Tellegens theorem and you can prove that the power generated is equal to power consumed by the load. Okay, so power generated by the source is equal to power consumed by the load. We have to prove. That is the main concept of Tellegens theorem. Hope you are able to understand. So let's try to review the things. Tellegens theorem is the fundamental principle of an electrical circuit. It is applied to RLC element. Okay, so it is the algebraic sum of power delivered by the sources is equal to power consumed by the elements. Okay, what he is saying is the algebraic sum of power delivered by the elements. For example, power. This also we can write on it as the algebraic sum of power delivered by the sources minus algebraic sum of power delivered by the elements will become 0. This also can be told as same. This the meaning is that the power delivered by the sources is equal to power consumed by the elements. So mathematically, this is obtained by the product of voltage and current, where voltage is involved. This network, this theorem involves KVL as well as KCLs. Okay, so this is applied to any network consisting of RLC elements, diode, transistor, all electronic components, passive elements, and time varying and time invariant also. Okay, so the importance of this theorem is this is useful in we can find out where the energy is lost and we can identify where the power is wasted, and by identifying that we can reducing the energy conservation. Okay, and this is useful in identifying where the problem is. This nothing but error detection, and by using error detection you can correct where the loss is there and you can minimize that loss. That's why this is called error detection. This is applied for uncomplicated networks like this. That's why this theorem is very important in the exam also. Okay, if you feel my explanation is good, please like the video and share with your friends, those who are studying this subject. If you have any doubts, let me know in the comment section. I can answer your doubt. So if you feel my explanation is good, please subscribe to my channel with the name KV Ram. Kindly support this type of free channel for the development of students and faculty. Thank you for watching the video patiently. Yours Ram. The next video will be on solving this problem number 54 and we are going to verify whether the Thevenin's theorem is really verified or not. Thank you for watching.